Okay, let's talk about absolute dependent motion of particles. In some textbook, it is also named as constrained motion of connected particles. What do we mean by this? If we consider two particles which are connected together, in order to analyze their motion, we need to consider the relation between the particles. The best example, or one of the very well-known example of this, can be given like this. Think about, you have a box which is pulled out by using a roller. Let's say if you carry a load like this, if this is a surface, this type of problem can be considered as dependent motion of two particles. If you consider box A as particle A, if you consider box B as particle B, and if you consider they are connected by a roller at this point, as you can see here, we can analyze the motion of two particles depending on how they are connected. So this is one case. In another case, you can connect, like if you consider the machines we use, for example, if you have a roller in order to carry a load like this, let's say, and you have another roller and this is connected to another roller, as you can see here, and there is another load carried here. Let's say you have a box A here, you have box B here, and you have box C here. As you can see, A, B, and C particles are all connected together using a roller and ropes, as you can see here. So, if you have this kind of problem, how can you relate the motion of A to B, B to C? And this is the problem type we want to consider under this title. So, for this type of problems, what we do, we usually consider a constant length. For example, what we can say here, the rope connecting A and B here have a constant length. And similarly, the rope that is connecting to A to B to C here has a constant length. So we can say that the length of these objects, we can say, let's say this is L1 and let's say this is L2. L1 and L2 have constant length, so it doesn't change. So this is an assumption that length of the rope connecting particles constant. So the length of the rope connecting the particles is constant, so this gives us some information. So if we define the position of the A and B, parts A and B, depending on a datum plane we choose, then using this length, the constant value of length, we can get some information about the kinematics of the particles. How? For example, if you consider this case right here, if we define, let's say we want to define a datum plane like this, we have one datum plane like this and another datum like this, we can define the position of A as this. This is going to be position of A, which we can give as SA, and also we can define the position of B, which we can say SB. And plus there is going to be a length right here, which wraps around the roller. Okay, so this is let's say this length to be omega, which is the wrapping around the roller. So L1, then L1 can be given as SA plus W plus SP. So we know that the wrapped amount around the roller is always constant. I mean, there is always going to be the same amount of wrapped length around the roller. So therefore, this is also constant. So we have two things constant. One, L1 is constant, and also omega, which is the wrapped amount around the roller, is also constant. Now, using this information, what we can do? We can get this information. L1 equals SA plus omega plus SP. Then if we take the derivative of L1 with respect to time, L1 with respect to time equals dSA over dt plus d omega over dt plus dsp over dt. Because this is constant, this is going to be 0. And because this is constant, this is going to be 0. What is SA over dt? It is the velocity of A. And what is dsp over dt? It is velocity of the B. So therefore, if we say 0 equals VA plus VB, and this will give us information that VA will be equal to minus VB. So this tells us that the velocity of A will be equal to velocity of B, but in opposite directions. And it is quite understandable. As you can see here, as A moves towards right, as you can see here, as A moves towards right, B will move towards down. So because A moves towards right, it will have a negative velocity because we have SA as positive in this direction. Because it moves in opposite direction, therefore it will have a negative velocity, and SP will have a positive velocity, but they will have the same velocity. So whatever the velocity of A will be equal to velocity of B, and this is obtained from math using this operation. Similar to this approach, we can do the same thing for this system here. If we determine a datum plane, if we consider a datum plane like this, let's say this is our datum, and we can define the position of A as this, SA, position of B, you can determine position of B as this, right here, and let's put it here, and C, the position of C here. Okay, so what is the length of the rope? It's going to be, as you can see here, there are going to be, let's indicate by this. As you can see here, there is going to be one SA, two SC plus the wrapped amount, and also one SC. So if we consider the total length of the rope, it's going to be this plus this wrapped amount, this wrapped amount, and this wrapped amount. And also we need to dissect, because we consider SP here, we need to subtract this length right here. So, but we know that this is all constant. So instead of doing this lengthy way, using the idea that we already used here, what I'm going to do, I'm going to define, so I'm going to draw the rope here again. So it's something like this, and we have a roller here. Instead of defining SA, SP, and SC like this, what I can do here, I know that because they will move with the same instant, I'm going to define SA as this. SB as this, and SC as this. Okay, so this is going to be SC, and this is going to be SB. So based on this, as you can see, total length can be given as this plus wrapped amount, this plus wrapped amount, this plus wrapped amount, and this total length is going to be like this. So if we write the total L2, if we write L2 here, it's going to be, as you can see here, 1 SA, 2 SB, they're going to be 2 times SB, and 1 times SC, plus wrapped length. So I just excluded all these. So we know that L2 is constant and wrapped length is also constant. So therefore, if I take derivative, dL2 over dt equals dSA over dt plus 2 times dSB over dt plus dSC over dt plus d omega over dt. This is 0, this is 0, and this is velocity of A, this is velocity of B, and this is velocity of C. And because of this reason, I can say 0 equals VA plus 2VB plus VC. So this will give us a relationship between, it will give us the relationship between velocities of A, B, and C. And based on this, if we take derivative once more, you can get the information about accelerations as well. So therefore, 0 is going to be equal to AA plus 2AB plus AC. So by taking derivative once more, you can also obtain the information about accelerations. So this is the main outline of the absolute dependent motion of particles. This is the main idea. Okay, let's solve an example about absolute dependent motion of particles. As you can see here, we have a system with pulleys and ropes, and at point A, we apply a load so that we can give 1 meter per second velocity for A. So correspondingly, what is going to be the velocity B? So here, different than the basic examples I explained in the explanation part, we have not just one rope, we don't have just one length, we have a couple of lengths. So let's indicate those. For example, we have this rope right here, we have another one here, and we have another one here. So we have basically 3 ropes. So we can write the relationship between the velocities and the pulleys. So in order to do that, let's give the name pulleys. If this is A, B, let's give this pulley C, this is pulley D, this is pulley E, and this is pulley F. So based on a datum plane, let's put our datum plane here. So let's put our datum here. Based on this datum, we can define the positions of A. This is going to be SA. The position of pulley D, which is going to be SD. And the first length, So if we were to write the length 1, so let's say this is row 1. I'm going to use a different color for this. If this is length 1, then we can write L1 as SA plus 2SD. SA plus 2SD. And correspondingly, we can say that dL1 over dt equals dSA over dt plus 2 dsD over dt. And based on this, 0 equals VA plus 2VD. And because VA is given downward 1, which is the positive 1, so this is 1, then we can say that VD is going to be minus 1 over 2 meter per second. So the pulley D will have a velocity of minus 1 over 2 meter per second, which means it is going upwards. Upwards is negative. Why? Because SD is defined as downward positive. So this is important. Okay, so now I want to do the same thing for the length 2. So this is L2. I want to do the same thing for L2, but now I want to define the defining for length 2. I also need to define SE, as we can define SE here. This is going to be SE, and how can we define, let's put datum here. So how can we define L2? Look at here, this length here, SD minus SE, and here we have SE, right? And we have also Bragg amounts. So this part right here is SE minus SD, right? So the total length is going to be SE minus SD plus SE. So length 2, for length 2, we can write SE minus SD plus SE. Okay, so this which is SE minus SD plus this which is SE. So length 2 is going to be SE minus SD plus SE. So which means it's basically 2SE minus SD. So based on this, if we take the derivative, dL2 over dt equals 2 dSE over dt minus dSD over dt. And therefore, because this is constant, this is going to be 0. 0 equals 2VE minus VD. And from here, we can say that VE is basically VD over 2. And because VD is given as minus 1 over 2, it's going to be, VE is going to be minus 1 over 4 meter per second. Which means E is also going upward. Okay, so E is also going upward because SE is defined as downward positive. Okay, so now last, what we can do, we can relate the E to the F. F also means the pulley F, the displacement of pulley F also means the displacement of B. Okay, so there is going to be only this length right here, but because this is a constant length, you can just say that F and B will move with the same displacement. Okay, so just to avoid confusion, I'm going to erase some of these so that I can show better. Now, if I want to define the length or the displacement of F is F, and if we define E, as you can see here, as E, the total length of L3, this is L3, length 3, the total length is going to be, as you can see here, SF minus SE plus SF. So length 3 from here, length 3 can be written as SF minus SE plus SF, which means it is 2SF minus SE. So based on this here, dL3 over dt equals 2 times dSF over dt minus dSE over dt. And this is 0, this is VF, and this is VE. So based on this, 0 equals 2VF minus VE, and from here we can say that VF equals VE over 2. And VE was already 1 over 4 minus 1 over 4, then we can say that VF equals minus 1 over 8 meters per second. So again, this is going upward. Why? It's negative because SE choose as downward, so therefore VF is going to be minus 1 over 8. And we know that VF and VB are equal to each other. VB equals VF. Why? Because they are just connected by a rigid, as you can see here, a rigid length, a rigid rod, as you can see here, which means they will always be same. Okay, so therefore B will be equal to VF, which is B minus 1 over 8 meter per second, which indicates that it is upward. So this is the answer of the question.